Now we're getting ready to unfreeze the whole model and retrain it again. So now what happened was that if you run the learn summary again and scroll towards the end, notice now there's 25 million parameters. All of the parameters are trainable. You can see non-trainable parameters has been set to 0 because everything's going to be trained. We're going to run this learning rate finder, which is a clever little tool to find those learning rates. I discussed that a little earlier, how it uses this one cycle approach to find the learning rates. And this learning rate finder here, you can read up more about it when you go to like the documentation and you go into basic training. In the basic training page, they discuss more about all this stuff, how to find the learning rates. And this is the function we're going to be running. And you can see that it sets up a start range, a very low learning rate, 1 neg, -7, which is really low, and then high is up to 10. So you can see as it bumps up this learning rate per iteration, you can see it plots against the loss, what happens to the loss. And obviously you want to get the loss down. That's the whole purpose of this. So that's what this learning rate finder is going to do. So let's run that. And this might take a little while too, because it's going to, keep running through all those epochs, and it's set it to run about 20 times right now. So this might take a while. Once the loss, once it bumps the learning rate up enough, you will see a sharp increase in that chart that we just looked at. This thing will start climbing very rapidly up. And what we're interested in is this area here. And that's what we're going to be finding out, which learning rate or which range of learning rates we want to use. So we're going to run the learning rate finder, and then we're going to pick something to use. Now it's done. Looking at this, it doesn't look too promising. You can see it starts at training loss of 16, goes down to 14, 15, 15, 16. Keeps going down gradually here, but then it starts turning right around 1250, starts going up again, and of course it shoots up, it diverges. So it found it went through about 18 seconds per epoch, and it did 15 of them. So let's plot and see what it looks like now. This is my previous one, what it looks like. As you can see, that just like I thought, it's pretty flat going here. Judging from looking at this plot here, it appears to be the best area of training is what this goes the steepest down. So anywhere between 1 neg 5 and about almost to 1 neg 3 seems promising to me. You can also try to find the best rate. Keep in mind, it's pretty bumpy here, so it will give you 1 point. And you do this recorder plot, and you pass in this suggestion is true, and it tells you that this is the best learning rate area. Now, it usually gives you in this 1 neg 0.6. I have a hard time understanding how many zeros that is. So I usually convert it into the decimal. So that's what this little function does. So when I run that now, it tells me that the best rate was 0.000002. Okay, so that's what it suggested. Now I'm ready to train the whole network. Keep in mind, all the parameters will be trained now. All the, 23 million of them. So what I can do is I can fit one cycle, and you can choose how much you want here. I'm going to try 6 epochs, and this max learning rate that I'm going to be using is going to be a range instead of just one number. And there's a reason for that. So if you go to this learning rate range, it tells you how this slice operation is distributed. So take a look at this and how it basically uses the beginning in the early layer and the end slice in the late layers, and then geometrically space out the others. So you can read up about that under this learning rate range. So what I chose was 1 neg 5 up through 1 neg 3, and it would be this area here. So that's what I'm going to be using. So I'm going to try to fit one cycle, 6 epochs. And I'll pause the video so you can see the result when it's done. Now it's done running through those 6 epochs, and I managed to get the accuracy up to 97.5%. Now, when I ran this model before, as you can see here, this is the highest number that I have gotten to for running these models. So in another notebook, I have it sitting, the model was saved with a 98.75. And you can see the error rate is very low, about 1.25% error rate. So that's how you train this model. You can play around with number of epochs. You can run it for a lot more epochs and see if that improves it. But I kind of plateaued out around 98.75, which is pretty darn good because that's almost 99% accurate. One thing I can do is use the learner and show the results and tell it how many results you want to see. So in this case, I chose 3 by 3. And if you look at this, you can see the ground truth versus the predictions. So this top label is the ground truth, that actual label, and the prediction is the second one you see here. So if you look at these images, everything was spot on. There was no errors made. So everything was precisely predicted. Again, if you want to look at this function and what it does, I'll show results. Just do a dock in front of it and you can see it. You can also plot the losses. This is what the losses look like. So there's a function for that. You can see training versus validation. This might be very useful if you have a lot of batches, a lot of epochs you're running, so you can see whether or not you start overfitting, meaning this validation start climbing up while the training data keeps going down. That's a classic sign of overfitting. Another thing you can do, you can plot the matrices. So here's what that looks like. Accuracy versus error rate. There's another method. So now you're ready. Once you're happy with your model, you just save it one last time, okay? And then you can run your model some more and save it again and again. Another thing we can do is there's this function called classification interpretation from learner, and you're passing in the learner. And I create a variable called interp, and when you run that, it will run some statistics over the result set that you created. And what you can do now is you can plot the top losses. This will tell you which one for example, has a prediction, and then is the actual, then the amount of the loss, and the probability. So as you can see here, the prediction was normal, the actual was pneumonia, and the loss was this much, and probability is 0. So if you look at the other images here, it appears to be these two images that was incorrectly classified. The rest of them appears to be correct. It has the same label for actual and prediction. So it appears to be two images that it had problems with. So you can also run this most confused. That tells you the labels of these images that you saw up here. And you can also create a confusion matrix that will give you a nice little display. For example, from the validation set, there was the actual is on this axis and the predicted is on this axis. And you want to look diagonal. That's the one you want to look at. So for example, the actual was 35 on that was normal. That was predicted as normal. That there's only 2 of them that were not working right. This is not where you want to be, because this is you predicted to be normal, but you actually had pneumonia. So that's not a good sign. But there's only 2 images that I had problems with out of all these 80 images that it was validating against. And finally, you can save your model for export, so you can use it in other environments by using this learn.export and then save it with a pickle extension. A pickle is like serialized result. This will pack up your whole model, all the weights, everything, and put into this file.